Assalamualaikum and good day everyone. This is a recorded lecture for additional examples of chapter 3, which is special distributions. Previously we already touched about the Poisson distribution and also binomial distribution and normal distributions. So for this recorded lecture, so I would like to explain to you about when we need to use Poisson approximations given that the problem is binomial. So we need to look at into this property, which is when we have problem n is large, which is n is greater than or equal to 30, and also p is very small, p is less than 0.1, then we need to use Poisson approximation instead of using binomial. So this is the problems given. Okay, but we have n greater than 30 and also p less than 0.1. So we need to convert the binomial into the Poisson. Okay, so we know that the equation of Poisson is basically probability of x given value of x is equal to exponential negative mu mu power of x and x factorial. Okay, so we need to use this formula, but we need to make sure we have the information like mean. Okay, we know that mean for this change of binomial to Poisson is equal to n times p. Okay, so normally binomial we have n, we have p, we have q. Okay, so we need to find the mean, okay, which n times p. So we will look at the first example. A manufacturer of power lawn mower buys engines in a lot of 1,000 from a supplier. She then equipped each of the mower produced by her plant with one of the engines. So history shows that the probability of any one engine from that supplier defective is 0.001. So this is probability of defective referred to P. Okay, in a shipment of 1,000 engines, what is the probability that none is defective? So the P, our P is the probability of defective. Okay, so we know that the probability of defective P is referred to 0.001, and then we have n, the number of shipment is thousands. So if we refer to these properties, we can see that n is greater than 30 and p is less than 0.1. So we cannot use binomial, but we need to use the Poisson. So what are the information needed is we need to find mean, which is n times p. So it's equal to 1,000 times with 0.001. So this is equal to 1. Okay, then you have the information. So what is the questions? So the questions ask you to find the probability that none is defective. So the x, the number of defective is 0. Px equal to 0, or we can do like this. Okay, so it means that we need to use equation of Poisson, which is exponential negative mu, our mean is 1, time with 1 power of x is 0 over 0 factorial. So you calculate using your calculator, then you get the final answer is 0.3678. Okay, so this is the first example. So we will look at another second example. Diabetes is a chronic health condition where the body is unable to produce insulin. So we have the probability lead to blindness here. So this is our probability. Assume that the distribution of the diabetic patients that will lead to blindness is binomial distributed. So it's follow binomial distributions. And then we have n is 2,000. So find the probability that the patient diagnosed will lead to blindness. And then the second also will lead to blindness, which is we are using P is probability of blindness. Okay, so we need to write up the information. Given P is 0.0202 and also N is equal to 2000. So this is bigger than 30, this is less than 0.1. So of course, we cannot use binomial, we need to use Poisson distributions. So we need to find the mean, which is n times p. So 2000 times with 0.002, you get this is equal to 4. Okay, so A, they ask you to find the probability fewer than 3. So fewer than 3 is less than 3. And also the second one is exactly 7. Probability, the number of patient is exactly 7. So this is the problem you need to solve. Okay, so means that this one is you will have x equal to 0, 1 and 2. So probability of x0 plus probability of x1 plus probability of x equal 2. Okay, so you need to input the value of x into the equation of exponential. So we have exponential negative mean. Our mean is 4. And then we have mean power of x over x factorial. So we have 3x here. x0, x1 and x2. So you will have to input for every x 3 times. Different x. So we have exponential negative 4. 4 times 1. 1 factorial plus exponential negative 4. 4 times 2 power of 2. 2 factorial. Okay, then you get the answer. Same goes to this one. So we know that this equation is when probability of x equal x. So this is equal sign. So we just need to find the probability of power of 7 factorial. What is our answer? Okay, so this is the solutions to that. So like I said, probability x less than 3. So we have x0 plus x1 or plus x2. So we need to substitute the x into the equations. We know that the mean is 4. So substitute mean, and the only difference is x for every x here. 0, 1 and 2. So by using your calculator, input the value, you get the answer here. Same goes to the B. So bpx equals 7. So you need to input the value of x. Then you get the final answer. Okay, so the next one. So this is the next example. So the rate of germinations for a particular type of paddy seed is 0.75. Find the probability that from a random sample of 10 seeds, less than 8 seeds will germinate. So will germinate. So that is the probability. So we need to use this as a P. So for A, we have P equal to 0.75 and also N is equal to 10. So the questions is asking to find the probability less than 8. So this is the questions. So right now we need to check whether we need to use Poisson approximation or not. So since n is not greater than 30 and p is greater than 0.1, so this one can use binomial distribution. Okay, which is you need to find NP, you need to find for the NP, sorry, it's not NP, so the equation is PX NCX, and then we will have P power of X and also Q power of N minus X. So this is equation of binomial, so you have this one. Okay, so this is basically from 0, your x, possible x is 0, 1 up until 10. But you only need 0, 1, 2, 3, 4, 5, 6, 7 only. So what is the number that you don't want? So you don't want 8, 9, 10. So instead of using calculate from 0 up until 7, you can actually calculate the value, which is, this is equal to 1 minus probability that you don't want the x, which is x is greater than or equal to 8. So here you don't want px equal to 8, you don't want px equal to 9, you don't want px equal to 10. So the value of x here need to be substitute into the equations here. Okay, so later we show you how. So for the B, the next questions is the rate of germinations for the same type of paddy seeds is 0.94. So by using suitable approximations, find the probability that from a random sample of 86, less than 5 seeds will not germinate. So the given probability just now is germinate. So the question asks you to find the probability not germinate, which is the opposite of germinations. Okay, means that your P right now is the rate of not germinate. And then the Q is rate of germinations lah. Okay, which is given equal to 0.94. So we want to find the rate of not germinate. So the P is 1 minus 0.94. So here you can get 0.06. And then we have N. N is 80. So do we need to use approximations? So since N is greater than 30 and the P is less than 0.1, we need to use Poisson these approximations, which is you need to find the mean N times P. N is 80 times 0.06. Okay, so you get the answer. So let's look into the answer one. So A, so this is binomial distribution. Since N is less than 30, P is greater than 0.1, we can use binomial. So this is equation of binomial. And then you need to find Px less than 8. So instead of finding 0, 1, 2, 3 up until 7, you can actually minus the probability total 1 minus the probability of 8, 9, 10. Okay, so it's less work than finding all of this. Okay, so by substituting x, where do I get this one? So this is coming from our N is 10, C, our X is 8, P is 0.75, and then our X is 8, and then we have Q 0.25, N minus X 10 minus 8 with 2. So same goes to 1. So this is 10 C9. 0.75 power of 9, 0.25 power of 1. And this also x equal to 10. So 10 C10, 0.79 power of 10, 0.25 power of 0. So you get the value there. Okay, so binomial. So B is using Poisson approximation. Why? Because N is greater than 30 and P is less than 0.1. So we need to use Poisson approximations. So we need to find mean and P. So 4.8. Substitute into the equation of Poisson here. So P, for the problem is to find Px less than 5. So means that x equal to 0, x equal to 1, 2, 3 up until P 4. X equal to 4. So you need to calculate it one by one. Okay, so this is like I already simplified the problem, the equations. So actually you need to input. Okay, calculate negative 4.8 and then 4.8 power of 0. 0 factorial plus when x is 1. So you need to calculate one by one. up until when x equal to 4. 4 factorial. Then you get the final answer. So this is when you need to do the Poisson approximations. Okay, so the next one is we're going to look into when we need to use normal approximations. Okay, given that there is binomial lah, the problems. So when do we need to use normal approximation? When n is considered large, very large number, like n is greater than 50. Okay, so p is sufficiently small, then we need to use normal approximations. So this is the table that you need to do corrections on the value of interval or value of this one. Okay, so you just need to remember 2 only. Okay, like greater than, you need to plus 0.5, less than or equal 0.5. And then the opposite sign of that, you need to minus. Okay, so we will look at the first example. Suppose we want to know the probability that a coin lands on head less than or equal to 43 times during 100 flip. In this situation, we have the following values. Number of trial is hundreds. X is the number of success. P is the probability of success. Y is 0.5 because it's either head or tail. So the probability of getting head is half. Probability of tail is half. Okay, so since n is considered large enough, okay, and P times 50 and times Q, okay, is 50. So we need to use normal approximation lah. Okay, because of n is greater than 50. Okay, so mean. So because we know that normal distributions, we have probability of Z. Okay, Z, right? We have Z, let's say greater than Z. So you will have Z, and then you will have PX. This is PX. PX, let's say greater than T. So we need to change it to normal. PZ T. So you need to plus 0.5 or minus 0.5. It's depend on this notation. So because this is greater than, so it's plus 0.5. And then you need to minus with mean, divide by the standard deviations. So this is normal approximations. You need to have mean and standard deviation. So the mean is equal to NP, and then the standard deviation is square root of NPQ. Okay, so what do we need? The questions ask you to find probability x less than 43. So probability x less than or equal to 43. So since this is less than equal, so you need to adjust the value. So you need to add 0.5. So it's actually px less than or equal to 43.5 based on this table. Okay, less than, we add the value 0.5. Okay, so means that we have the mean 100 times 0.5 is 50. Standard deviation is square root, you get 5. So this is the problem, which is you need to change this into Z, less than or equal 43.5 minus the mean is 50 over the standard deviation is 5. So the probability of Z less than or equal to negative 1.3. Okay, so we already learned this before. How can we draw the shaded regions? So this is negative sign, it's on the left side. So you get this one. Okay, like I say, this is also equal to 1.3 on the right side. Okay, so you need to, this is, we will using this. So this is equal to PZ greater than 1.3. So if you refer to the table, 1.3 is 0.0968. 0.0968. So this is the final answer. Okay, so we look into the next one. Random sample of n. See, n is very large number, and then ongoing production process in which 8% of all such tire produced are defective. What is the probability that 150 or fewer tires will be defective? So our P is defective. Probability of defective. So this is 0.08. We have n is big N. So of course when we see the N is very big, so we need to use normal approximation. So we need to find the mean. NP 31600 times with 0.08, and also the standard deviation NPQ. So this is 1600, 0.08. The Q is 1 minus 0.08, 0.92. Okay, then you get this is 128. This is 10.85. So the questions ask you to find the probability that 150 or fewer. So 150 is included. So less than or equal, we need to plus with 0.5. So we need to change this into probability of x less than or equal to 150.5. So again, need to do the normal distribution, change x into z, the value minus with the mean 128 over the standard deviation 10.85. You get pz less than 2.07. So this is the equations. Okay, means that how can we use the table? So it's actually all of the distribution, which is this is equal to 1 minus with on the right side 2.07. We don't want. So this is also equal to equation number 2 here to get the graph probability here. Okay, so 2.07 is 0.01923. 0.01923. So 1 minus 0.01923. Okay, so it's basically like this lah. 0.0, is it 0.01923? Yeah. So you will get the answer is 7. 92 is 7. 99 is 0. 8. Okay, it's actually 0.8077. Okay, 2.07. Is it 2.07? Yeah, 0.01923. Is it correct? No. It's wrong. So it's basically 10.3792 is 7. 99 is 0. 91 is 8. 90 is 9. So 0.9807 or 0.9808 just now. Okay, So the second example, about 10% of the property is left-handed. So the questions ask you to find the property of left-handed. So we will have the same P, left-handed. So 10%, so probability is 0.1. And then we have N is 150, which is quite large. So we need to use normal approximations. So need to find the mean, NP, and also the standard deviation, square root of NPQ. So our Q is 0.9. So you will get the mean is 15, and then the standard deviation is 3.67. Okay, so questions ask you to find the at least, which is at least 25 included, and then between, the second one is between 15 x and 20. So you need to do the approximations, px, because it's greater than or equal, so this is need to be adjusted. You need to minus with 0.5 based on this table. Okay, minus 0.5. So minus 0.5, so this is 24.5. And then this one, probability of x greater than 15, so you need to plus with 5. And then x less than 20, this is need to be minus with 0.5. Okay, then you need to actually calculate the z normal. Okay, so change by minus with the mean and also divide by standard deviations. So z is 2.59. So we need to draw the shaded region of the bell shape. So 2.59 is this part. Okay, so which is we can automatically find the answer using the table. 2.59, which is 0.0048. So this is our answer. And then the next one, okay, to calculate the z. Okay, then we get it's actually PZ between 0.14 and 1.23. So we need to draw the bell curve here and then shade the region. So 0.14 and 1.23 is on the right side because it's positive number. So the shaded region is in between this value. Okay, but the graph is basically is for until the end of shaded. So means that to get this shaded region, so we need to have the total of 0.14 greater than 0.14 minus with this one. Okay, so you will have this part. So you need to find PZ greater than 0.14. So 0.14 is 0.4443. Okay, 0.443 minus with 1.23. So 1.23 is basically 0.1093. Okay, then you get the final answer. So that's the end of part of approximations. So you need to know when to use the Poisson approximations given the binomial, and then when to use normal approximation given the binomial distributions. So hope you will understand this lecture. So thank you for